Welcome back. This presentation includes some general procedures and information you need in order to apply it to the specific types of approaches. Preparing for an approach is really an important part of the flight and should really ideally start before the flight even takes off. Nearing your destination, though, the controller or the ATIS will tell you what to expect for the instrument approach procedure. But until ATC says that you're cleared for the approach, you have not been cleared for the procedure, and so you can't descend to any of the altitudes or take any of the courses until you've been cleared for the approach. ATC will clear you for a specific approach if there's more than one choice. But if you want something else, you can always request it, but do so immediately. You can execute the entire route from the feeder route or initial approach fix unless you're being radar vectored for the final approach course. You have to be very organized and disciplined about the way you brief the approach. You should have, every pilot has their own technique for doing this, but you should work this out with your CFII, and whatever you choose, you should stick to it. A lot of people use mnemonic like iMartha. We'll run that through that. It hits all of the things that you need. This may not be the technique that you actually use, but it works well. The I in iMartha starts with identifying that you have the correct approach for the correct airport. The M stands for missed approach procedure, which you need to review. A stands for the approach course and frequency, so that's the final approach course and the frequency for whatever nav aid that it uses. R stands for radios. Make sure that you've checked your weather and that you have all the frequencies programmed in that you're going to need during the rest of the approach so that you don't have to dial any knobs while you're trying to fly the approach. T stands for times. Check the times and write them down. Make sure you know where to look for them if there are times required for the approach. H is for headings, and what you look for here is the headings for the various transition route, the procedure turn, or try and predict what heading they're going to use to intercept you to the final approach course if you're getting vectors. Finally, altitudes. At what points in the approach are you going to be able to descend? And what are your minimums for this approach? In other words, what's the minimum descent altitude or the decision altitude that you're going to use to go missed approach? Cleared for the approach means that you are cleared for all of the routes and altitudes between you and the runway. If they just say cleared for the approach, they'll use that when there's only one choice, if the airport only has one approach procedure. Or once in a while, ATC will authorize you to just do whatever approach you want if it's quiet out. Cleared for the ILS 35 right. So this is typical when there's more than one approach procedure available for the airport and ATC wants you to do a very specific approach. This is the usual clearance that you're going to get. Straight in approach means that you're not going to do a procedure turn. And if you are flying a transition route that has no PT printed on it, or they have given you a straight in approach clearance, then you are not authorized to do a procedure turn. A straight in landing, on the other hand, means that you're going straight from the final approach course onto a runway that is aligned within 30 degrees. Sometimes it's not possible to design approaches this way because the nav aid's not aligned with any of the runways. In this case, there will be circling landings only. Make sure that you familiarize yourself with the category of aircraft that you're flying and be prepared to stay within the airspeed for that category especially during a circle to land approach. Make sure that you understand how the turn radius is affected by your airspeed and how it applies to a circle to land approach. Common errors in circling include descending below the MDA before you're in a position to make a normal descent to the runway, failure to stay within the appropriate distance of the runway so you get too far away, continuing the approach after losing visual contact, executing the missed approach without properly positioning the aircraft at the missed approach point, and then finally failure to establish a stabilized approach to land. Some airports allow ATC radar to be the approach, and these are not published as a plate, but there are two basic types: airport surveillance radar and precision approach radar. ASRs are designed for high-resolution short-range coverage in the general vicinity of the airport. Non-precision approaches are available at airports that have an approved ASR procedure. ASR provides radar vectors to the final approach fix, then azimuth information during the approach. As you make the approach, the pilot is advised of the MDA, when to begin the ascent, and when at the MDA. If requested, recommended altitudes will be furnished each mile along the approach. PAR approaches give highly accurate navigation guidance in both azimuth and elevation. Pilots are given headings to keep the aircraft aligned with the runway and are told to anticipate a descent about 10 to 30 seconds before it's needed. And then they are told again when the descent should begin. They will give you a decision height if you request it, and deviation from the glide path is notified to the pilot if it happens. Again, there's no graphical representation of this, and it's probably unlikely that you're going to use either an ASR or PAR approach except in an emergency. If you do need one, it is good to know that an airport is approved for it, and you can find that in the chart supplement. Those approaches should not be confused with radar required approaches. Some IFR approaches require that you have radar service in order to use them for some reason. This usually is associated with either vectors being required to get on to final or vectors being required for the missed approach. If radar service is available in an airport area, radar vectors are usually available to get you onto the final approach. And in terms of workload, this is really usually the best choice for the pilot. They will give you a series of headings that form essentially a downwind, base, and then a 30-degree intercept to the final approach course. These really reduce the workload for the pilot, but they do come with a responsibility to keep track of where you are during the vectoring. This is a good time to remind you that minimum vectoring altitudes exist. These are something that is only available to the controller. That's not something that you can really look up easily. But you can always ask what the MVA is in your area. Remember that this may be an option if you're having an emergency and want to get lower than the published minimums for your area. They may be able to take you down to a lower altitude if they have you on vectors. Procedure turns are used to reverse the course or realign you with the final approach course. The standard procedure turn keeps you within 10 nautical miles of the primary nav aid or a fix on the approach chart. Max speed for the procedure is 200 knots. If you are above the altitude designated for the course reversal, you can descend down to that altitude as soon as you're outbound on the procedure time, as long as you have a clearance first. It's really important that you hear cleared for the approach before you start descending to any of the altitudes on your approach plate. If a racetrack or teardrop is depicted, the turn must be flown exactly as shown, including the holding pattern entry if that's what's depicted. However, if it's only a barb, such as on the plate on the right, then how you turn around is up to you. Though the headings on the barb work fine in most instances, you may want to change it up a little bit if you have a strong crosswind from either side. Remember, though, that procedure turns are always required except for these 5 instances, which you can remember with the acronym NORTH. So, not authorized, so that's when they have no PT written on the chart for a transition. Otherwise directed by ATC, so if ATC says cleared for the approach straight in, then you're not authorized for it. If you're being given radar vectors, you never do a procedure turn. Timed approaches from a holding fix are in effect. We'll talk about what that means here in just a second. And then a holding pattern or teardrop entry is depicted in lieu of a procedure turn. So that's if that racetrack pattern is there. Then you have to do the holding pattern entry instead of the regular little turnaround. Timed approaches from a holding fix are used when radar services are not available for some reason. Either you don't have coverage in your area or there's been an outage. What they can do is stack airplanes up at some approach holding fix outside of the final approach fix every 1,000 feet or so. And then they clear the bottom airplane for the approach to start at a specific time. And then it's up to that pilot to time their holding pattern so they cross the holding fix at the assigned time, and then they can continue on inbound. Once they're on their way inbound and have reported that, which is a required report, then ATC can move all the other aircraft down. And so everybody waits for their turn to go inbound. In order for timed approaches from a holding fix to be approved, then there have to be certain conditions met. One is that there's an operating control tower. That's so that the control tower can let ATC know that you've made it to the airport so that they can release the next aircraft. Number 2 is there has to be direct communication, and that's fairly obvious since you can't be assigned your approach time without that communication. There can't be any course reversals on the missed approach. So in other words, the missed approach can't have you going back to the holding fix. Otherwise, you'd be running into the next aircraft. And if there's only one missed approach procedure for the approach, then the ceiling and visibility have to be higher than the highest circling minimums to ensure that you don't end up having a bunch of aircraft going missed to the same fix. Sidestep maneuvers are also commonplace when there are parallel runways that are 1,200 feet or less apart. The minimums for a sidestep maneuver are higher than a straight-in minimum, but lower than circling minimums. The thing that the FAA really seems to want you to know on the written test is that you should start your sidestep maneuver as soon as possible after the runway environment is in sight. A contact approach has to be something that is requested by the pilot, and they are essentially a shortcut. We use these when we can see the airport or see the landmarks and are very sure that we can maintain at least 1 mile visibility and clear of the clouds all the way to the airport. And it allows us to not do the approach procedure, which saves us probably 15 or 20 minutes of flight time. The disadvantage is if you make a bad judgment, then there's no real missed approach procedure for it. And you're going to be responsible for VFR traffic avoidance while you do the approach. Just make sure that you can really do it before you request it. A visual approach, on the other hand, can be initiated either by you or ATC instead of doing the approach procedure. For this one, you need to either have the airport or the aircraft in front of you in sight, and the ceiling has to be at least 1,000 AGL and the visibility at least 3 miles. So you need basic VFR weather conditions. You have to be clear of the clouds all the time on a visual approach. If you've got the airport in sight but not the preceding traffic, they can still issue a visual approach. But once you locate the other aircraft, you have to let them know right away, and then you have the responsibility for following that aircraft. Remember that in order to land, you need 3 things. The required visibility, which people forget about all the time. It's very important that you have the required visibility in the minimum section of your approach plate. Number 2 is you need to be able to descend using normal maneuvers. So you can't do radical slips or anything like that in order to get down. And 3, you have to have the runway environment in sight. So what does runway environment mean? One thing that can define runway environment is the approach light system. There are actually 12 things. The approach light system is special. If you can see the approach lights, you can descend down to 100 feet above the touchdown zone elevation, just using the approach lights. But you need to be prepared to go missed if you get down to 100 feet above touchdown zone elevation and still don't have anything else in sight. But it'll usually buy you enough so that you can get one of the other 11 things in sight. So these approach lights will buy you the right to break the minimum all the way down to 100 feet above touchdown zone elevation. It's important that you know what to look for, so you need to study those different various types of approach light systems. In order to go any further, you need one of the other 11 things of the 12 things on our shopping list. In order to fly below 100 feet above the touchdown zone of elevation, or in order to descend below MDA or your DH, if you don't have approach lights, you need one of these 11 remaining things on our shopping list. Now, this seems like a long list to memorize, but in fact, there's some repetition that you can take advantage of here. You need the threshold, the runway, the touchdown zone, or the VASI, PAPI, or the runway and identifier lights in sight. So it's fewer things than you really think. Both the threshold, the runway, and the touchdown zone include both those things themselves, any markings on them, or the lights associated with them. Once you get any one of these 11 things in sight, then you are good to go below the minimums for the approach. If you have the visibility and you can make the landing using normal maneuvering. Missed approach procedures ensure adequate obstacle clearance throughout the missed approach. Remember that you need to be flying at or below the maximum airspeed for your aircraft category in order for that to be true. Obstacle clearance is only guaranteed if you're executing the missed approach procedures at the missed approach point, however. So if you are doing a circling maneuver and you suddenly lose sight of the runway, you need to turn towards the landing runway and become established on the missed approach course before you start that procedure. What if you need to go missed approach but you're out of position? So let's say that you are still on final, but you get full scale deflection, and therefore you need to go missed approach. You should maintain your track and wait until you get to the missed approach point before you start the procedure. Now you can go ahead and start the climb early, just don't turn early. If you have to go missed approach while you're circling, you lose sight of the airport, for instance, you need to make a climbing turn towards the landing runway and then establish yourself on the missed approach course. The emphasis here is climb. Just don't turn towards the missed approach fix until you get yourself over the approach runway first. Remember, the important thing here is not to just turn arbitrarily towards the missed approach holding fix. You don't know what lies between you and that fix unless you follow the procedure.